12 of 15 API endpoints leaked user data because Cursor AI only added authentication to routes generated in the same prompt. It never retroactively protected the earlier ones. Let's break down built SaaS in 48 hours with V0 and Cursor AI, how it works, and the exact mistake behind that failure. AI-assisted SaaS building uses V0 for UI generation and Cursor AI for backend logic. The human defines the architecture and reviews the output, while the AI handles implementation details. This workflow accelerates development but introduces risks if security is not manually verified. The stack consists of V0 for frontend, Cursor for backend, and Vercel for deployment. TypeScript interfaces serve as the integration contract between the two AI tools. The human must define these interfaces and verify that components connect correctly. Here's the project structure generated by V0 and Cursor. V0 handles the UI components in the app and components folders, while Cursor generates the backend logic in the API and lib folders. The middleware, TS file, is critical for authentication. V0 generates production-quality React components from natural language descriptions. The key is prompt specificity, include design tokens, component library, and responsive behavior. However, the data layer, fetching, caching, error handling must be wired manually. Here's a dashboard page generated by V0. The visual structure is complete, but the data fetching functions like getDashboardStats must be implemented manually. V0 provides the skeleton and loading states, but you connect the real data. Cursor AI generates backend code based on project context defined in Cursor rules. The workflow is to define TypeScript interfaces first, then ask Cursor to implement the routes and queries. This constrains the AI output and ensures type safety. This is the Cursor rules file that tells Cursor how to generate code for the project. It defines the framework, database, auth, and coding standards. Without this context, Cursor generates generic code that may not match your project conventions. Cursor generated this Stripe webhook handler. It processes subscription events and updates the database. The code looks correct, but it lacks error handling for edge cases like missing metadata or Stripe API failures. Always review AI-generated code for security and robustness. This DashboardStats API route includes authentication via getServerSession. However, note that the auth check is only on this specific route. Other routes generated earlier may not have this check. This is exactly the kind of inconsistency that led to the auth bypass incident. Database schema and authentication require human architectural decisions. Design the schema manually, then ask Cursor to generate the Prisma schema. For auth, use a proven library like NextAuth.js and configure it with Cursor. Global middleware in Middleware, TS, is safer than per-route auth checks. This Prisma schema was designed manually and generated by Cursor. Note the indexes on email, created at, userid, and status. These are critical for query performance. AI-generated schemas often miss indexes, so always review and add them based on your access patterns. Here's the NextAuth configuration generated by Cursor. It uses credentials provider with JWT sessions. This configuration is correct, but the critical issue is that it's only applied to routes that explicitly call getServerSession. The global middleware is what should enforce auth on all routes. This global middleware uses NextAuths with auth to protect all dashboard and /API routes except webhooks and auth endpoints. However, this middleware was added late in the development process. Routes generated before this middleware existed were never retroactively protected. That's the root cause of the auth bypass. AI excels at generating boilerplate, UI components, CRUD operations, and integration code. But it struggles with architecture decisions, security review, edge case handling, and performance optimization. The human's value shifts from writing code to reviewing and verifying AI output. This breakdown shows that out of 29 hours of coding, AI generated about 70% of the code. However, 8 hours were spent reviewing AI output. Without that review, the app would have shipped with critical bugs. The review process must scale with generation speed. This is the same issue we highlighted at the start. Here's exactly why that happened. The prompt asked Cursor to add JWT authentication to the API routes. Cursor generated the auth middleware correctly, but applied it to only 3 of 15 routes. The remaining 12 routes were generated in earlier prompts before the auth middleware existed. Cursor did not retroactively add auth to existing routes. It only applied auth to routes generated in the same prompt context. Cursor AI generated auth middleware, but applied it to only 3 of 15 routes. The remaining 12 routes were generated before the middleware existed and were never retroactively protected. The fix involved auditing all 15 routes and manually adding the auth middleware to the 12 unprotected routes. A global middleware was added in Middleware, TS, using with auth that enforces authentication on all /API routes by default, with explicit opt-out for public routes like webhooks. Integration tests were added to verify every route returns 401 without a valid token. This route was generated before the auth middleware existed. It has no auth check, so any unauthenticated request can access all subscription data. Always audit every route after adding auth middleware, because AI does not retroactively fix previously generated code. The article mentions that AI-generated auth middleware was applied to only 3 of 15 routes. A safer pattern is to use a global middleware that blocks all /API routes by default and then explicitly opt out public endpoints, like webhooks or auth routes, using a config array. This ensures no route is accidentally left unprotected. The article focuses on authentication bypass but doesn't show how to implement per-route authorization, e.g., only admins can access certain endpoints. After verifying the user is authenticated, you should check their role or subscription tier. This is a common missing piece in AI-generated code. The article uses getServerSession from NextAuth, which is the v4 API. In NextAuth v5 beta, the recommended approach is to use the auth function from @libauth directly, which returns the session without needing auth options. If you're using Next.js 15+, consider migrating to v5 to avoid deprecated APIs. To diagnose missing auth, list all API routes and check each for auth middleware. Write integration tests that call each route without credentials and assert a 401 response. This catches routes that the AI forgot to protect. Let's run through some common interview questions. What is the main security risk of AI-generated code? AI often misses auth checks on routes generated before middleware was added. How would you ensure all API routes are protected? Use global middleware and write integration tests that verify 401 on unauthenticated requests. Why did the auth bypass happen in this build? Cursor applied auth only to routes in the same prompt context, not retroactively. And a few frequently asked questions. Can AI completely replace human developers? No, AI still needs human review for security, edge cases, and architecture. How much time should I spend reviewing AI code? At least 25% of development time should be spent on review. What is the biggest mistake when using AI for SaaS? Shipping AI code without reviewing authentication and data validation. Let's recap the key takeaways. AI handles 80% of implementation, but the remaining 20% is critical. Always review AI-generated code for auth, validation, and edge cases. Use global middleware patterns for security. Write integration tests that verify auth on every route. Ready to go deeper? Up next, introduction to JavaScript, then variables in JavaScript, then data types in JavaScript, and operators in JavaScript. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.